All right, for today's deep dive, we're going to travel back to a world that feels, well, almost alien to us now.
It really is a world where something as simple as a scraped knee
Or a blister. Or even childbirth.
could be a death sentence. We just don't think in those terms anymore. Before antibiotics, infection was the real killer.
I was looking at the sources, and that World War I statistic is just staggering.
It is. Of the 10 million soldiers who died, roughly half weren't killed by bullets or shells.
They died from the infections that came after.
Exactly. And that's the backdrop for our story today. The improbable development of penicillin, the first miracle drug.
And it wasn't one person's lone genius moment, was it?
Not at all. It was this incredible mix of science, total accident, and some brilliant engineering. It truly launched the golden age of medicine.
So let's start with the name everyone knows, Alexander Fleming. The myth is he goes on vacation in 1928, comes back.
And finds this magical mold on a petri dish he forgot to clean.
Right. But the reality is a little more complicated.
A lot more, yeah. He was already looking for antibacterial agents. He'd seen soldiers die from sepsis in World War I, so he was motivated.
And the mold itself was an accident.
A total fluke. A spore probably drifted up from a mycologist's lab on the floor below his.
But he was smart enough to see what it meant, that zone of inhibition.
That was the genius part. He saw that clear ring where the bacteria couldn't grow, and he knew something was happening. He isolated it and named it penicillin.
But then his discovery just fizzled out for a decade.
Yeah, his communication skills were apparently not great. His paper in 1929 was so dry it barely made a ripple.
Until the Oxford teen Howard Florey and Ernst Chain picked it up right as World War II was looming.
And they saw what Fleming didn't quite grasp. They proved it was non-toxic and, crucially, that it worked in vivo.
Meaning inside a living creature, not just in a dish.
Precisely. That was the game changer.
And the war added this insane level of urgency.
Oh, absolutely. I mean, the story of them rubbing mold spores into their lab coats.
Just in case the lab was bombed during a Nazi invasion.
Can you imagine? Just so the research could survive, literally smuggled out on their clothes.
That dedication is incredible, which they needed. Because making this stuff sounds like it was a nightmare.
It was a disaster at first. They were using milk churns, bathtubs, I think even trash cans. The process was so inefficient.
What was the yield like?
Terrible. 1 part penicillin for every million parts of the culture liquid. It took them 18 months just to make enough to treat a few people.
So this is where the engineers step in and save the day.
This is the pivot. The solution wasn't more biology, it was better engineering. A team at Pfizer, led by Jasper Kane.
And they came up with deep tank fermentation.
Right. They swapped the little flasks for these enormous 25,000-gallon reactors, bubbling sterile air through them and churning it all up.
That made mass production possible.
Yeah.
But they still needed a better mold, a better strain.
And that's the next lucky accident. A lab worker, Mary Hunt, found a cantaloupe in Illinois covered in this particularly potent green mold.
A cantaloupe.
A moldy cantaloupe. It produced 200 times more penicillin than Fleming's original. Wow.
And then they blasted that strain with X-rays to cause mutations and eventually got the yield up 1,000-fold.
So it's this combination of biology, engineering, and just finding a moldy piece of fruit.
That's the story. And the impact was immediate. By D-Day in 1944, they were producing hundreds of billions of units.
And the price just plummeted from $200 for a dose down to $6.
And deaths from pneumonia for soldiers dropped from 18% in the first war to less than 1% in the second. A true miracle.
But a miracle that came with a warning label from Fleming himself.
He saw it coming. In his 1945 Nobel lecture, he warned about underdosing, about exposing bacteria to the drug without killing them.
Essentially training them to resist it.
And he was right. Chillingly right. The first penicillin-resistant staph infection appeared just 2 years later, in 1947.
And now we're facing a global crisis. Antimicrobial resistance, or AMR.
It's a huge problem. The UN estimates we could see 10 million deaths a year from resistant infections by 2050. The economics are upside down, too. Penicillin's development cost a few $1,000s. A new antibiotic today. You're looking at nearly $1 billion.
So we need a new approach, a One Health approach that looks at humans, animals, and the environment together.
Things like better diagnostics, so you give the right drug for the right bug.
Exactly. And new payment models, like one being piloted in the UK, to incentivize companies to develop new drugs based on their value, not just how many pills they can sell. We have to stop misusing them.
It's an incredible arc. Penicillin's discovery created the model for how we do big team-based science.
Biochemists, engineers, microbiologists, all working together.
But it leaves us with this final thought for you to take away. We are now fighting a new war, a war against drug-resistant bacteria. And the enemy, in a way, was educated by our own misuse of the original miracle. So what really stands out when you contrast that scrappy, low-budget wartime rush of the original discovery with the billion-dollar struggle we face today just to stay one step ahead?